guys, welcome to the Data Science Festival. We're going to move on to the next talk. So it's going to be with Georgios Giasemidis of AUEB Sports Analytics Group. So his talk is going to be on Euroleague basketball analytics with Python, knowledge graphs, and simulations. So Georgios is a lead data scientist at Choreograph with a PhD in theatrical physics from Oxford. He's got a decade of experience in data science and AI. He combines technical experience with a passion for basketball analytics and is the creator of the Euroleague API Python library. If you could put your hands together for Georgios. Cheers.
Yep. Thank you very much. Thank you, everyone, for being here. And before I get started, thank you, the organizers, for organizing such a brilliant event. Yes, I'm Georgios Giasemidis, a researcher at Sports Analytics Group from Athens University of Economics and Business. And I'm going to talk about Euroleague basketball analytics with Python, knowledge graph, and simulation. So I'm going to cover all of that. So the work I'm going to cover is done in collaboration with several people, which I'm going to mention later in the corresponding sections. So this is the overview of the talk. So first of all, I'm going to, by the way, how many basketball fans are there in the audience? Oh, quite a few. That's good. So, but don't worry if you're not, if you don't know much about basketball. You don't need previous knowledge. So I'm going to cover that. So first of all, I want to cover why basketball analytics is important. And then the second section of the talk is I'm going to introduce the Euroleague API Python package that I created. What the motivation behind that and the impact it has on the community. The third section is how we use this data to unlock advanced basketball insights with knowledge graphs. And the fourth section is how we use this data to simulate the whole basketball season. So let's get started. Why basketball analytics is important? Because he gets on base? No. That's not the answer, but do you recognize this scene? It's from a movie. It's from the movie Moneyball. So Brad Pitt plays the role of a general manager from a baseball team, and his task is to make a competing team with very little budget. So he teams up with Jonah Hill, the character of Jonah Hill, who is a geeky guy all about numbers, and he tries to understand baseball game and talent through analytics. So they team up, and spoiler alert, they make a very good team. So I'm not gonna spoil the rest of the team. But the point here is that was the start of using advanced analytics in sports. Baseball was one of the first sports. So for decades, coaches, managers, and basketball experts look at traditional stats to assess players and teams' quality. And by traditional stats, we mean how many points a player scored, their field goal percentage, their three-point accuracy, rebounds, assists, blocks, this kind of stuff. That was the culture for decades. Until about 20, 25 years ago, when someone asked, which are the most and least efficient locations of the court? Of course, nobody asked this question. It was for dramatization, but that question was starting being asked by the community. And we can see here, so for people that are not very familiar, this is the percentage, how accurate is a shot taken at different places, locations on the court. So as you can imagine, there's no surprises here. If you shoot close to the basket, then your accuracy is over 60%. As you move away from the basket, you see it drops gradually to 40, 45, 30, 35, 40, and similarly in this direction with some exceptions in these spots. So all good, all makes sense, right? But there's this line, three-point line. So shots behind this three-point line are valued for 3 points. Everything inside that values for 2 points. So as you can see, there's this change of this jump from 2 to 3 points. And then we can start asking, what is efficiency? So efficiency we define as expected points per attempt. And then we can play a little game. So, for example, a 2-point shot with 40% accuracy, let's say from around this location, we're expecting to return 0.8 points per attempt. Okay, that's the expected score. But if we try a 3-point shot from up there with 30% accuracy, that returns 0.9 points per attempt. So basketball is a long game, a game with many attempts. And as you can see, in the long run, it's more efficient to score with 30% from the 3-point line rather than a 2-point from that distance. And suddenly, 3-point shots, in this case, are more efficient. And this is the efficiency landscape. So what I described just before with an example, so you can see here the expected points are 1.2 under the basket. As we move aware, the efficiency drops. And suddenly, once we cross the 3-point line, the efficiency again jumps above 1. And the most efficient locations are under the basket and in the corner 3-point shot locations. These beautiful visualizations are taken from the book Pro Ball by Kirk Goldsberry. So I definitely recommend that if you're interested in this topic to have a read. So the community realized that actually 3 is greater than 2. All right? And it's funny, but actually, yes, 3 is greater than 2. And from 25 years ago, we see here mid-range. Oh, yeah, mid-range is considered any shot here in this, inside the line, outside this rectangular, okay? And they are the least efficient, as you can see, all right? So there was a lot of mid-range shots back in the 90s, like Jordan, like the master of mid-range. So the community realized that 3 is greater than 2. So the mid-range started dropping because it's not that efficient, and the 3-point attempts starting like skyrocketing over the years. So this is until the year 2022, 2023. Another visualization of that is like this, how the game has changed. On the left-hand side, you see the most popular location 20 years ago, and until these are the most popular locations until in the last year. You see how the patterns change. So from mid-range, only in the paint, and outside the 3-point line. So we entered the era of Steph Curry. Okay. In the meantime, as this transition was happening, this guy appeared also the best shooter in the world in the basketball history. And so we entered the era of Pro Ball. And all that were driven by advanced basketball analytics. So I hope I have convinced you until now how a simple question, how analyzing a little bit deeper the game transformed how the game is played. So that's why basketball analytics is very important. All right, that was all about NBA. What is happening in Europe? I was born in Athens, Greece. I grew up there. I followed basketball in Europe. So yeah, that's my passion. So the top tier competition in Europe is called Euroleague. So anytime I say Euroleague, just think about European basketball. All right, and the format is slightly different from the NBA, and also the rules are slightly different, and that makes the dynamics of the game a little bit different. But essentially, I'm going to talk about basketball in Europe and data analytics in Europe. So Euroleague means European basketball, all right? So the next session is the motivation and impact of the work I started. So how this is started, that's the motivation. So it's all started while I was playing an informal competition of predicting Euroleague basketball games with my friends. And I was very bad. So one friend told me, "You suck." All right? And indeed, so I thought I might not know much about basketball, but I know about data. All right? So my question was, can I make a model that predicts Euroleague games outcomes better than individual experts? I was pretty confident that I can do that. But I needed data. all right? And that's an angry representation of myself asking for data, for Euroleague data. So where is the data? I started looking for the data, so I couldn't find. So if you go to the Euroleague official website, you see a nice dashboard here with some filters. That's all good. But these are the very basic statistics, all right? And first of all, was very basic. Second, there are no official API endpoints, so because I wanted to process that programmatically to create my models. I didn't want to grab by hand manually or even doing web scraping kind of thing. I hate that. So I wanted something automatically and easy. So I started asking on the community, where is the data? I started asking on Twitter, Reddit, the community, and with the support of the community, we tried to find some API endpoints, and like these ones here. And actually, some of them, we identify them literally by, once we found the base API URL, we started experimenting with like box scores, things like that. And some of them, we found them totally by trying random API endpoints. So some of them are hidden. Some other API endpoints are well documented in the Swagger API platform, this one. But that was also, it's not anywhere documented. All right, so once I identified all these endpoints, I started using them. And at some point, I realized, OK, it's time to democratize Euroleague data analytics. And the motivation came from NBA again. So in NBA, the API there is well documented, and it's free, publicly available. And there, in Python, there are some nice packages where you can use to grab and fetch the data very easily. So I thought, let's create a similar package for Euroleague data, so democratize Euroleague data analytics. And I created the Euroleague API. So it covers many data sets. It's documented in the link here on GitHub, on the GitHub page. And it covers both Euroleague and EuroCup. EuroCup is the second-tier competition in Europe. So it covers play-by-play data, shot locations, game box scores, stats, report, team comparison, metadata, team and player, both traditional and more advanced analytics. And on top of that, we did a little bit of work to derive lineups. Lineups meaning that the players that are from each team that are on the court, every single action covered by play-by-play. So, and that was a game changer because you can do so much more analysis knowing what are the players that on the court every time an action is reported in this data. I will elaborate about this data set. And the point is that with literally 3 lines of code, someone can download the whole history of, let's say, play-by-play data of Euroleague, like 15 years of games. OK? So how to use? I gave a webinar with the Shot Clock podcast. Shot Clock is a very popular basketball podcast in Greece. So the webinar is in this YouTube video. The intro is in Greek, like 2 minutes Greek intro, but the whole webinar is in English. So please go ahead, if you want to. And I give also a notebook, how to use. I cover some very basic use cases. So you can have a nice start using the library. We don't want to listen to that, all right? The impact it has on the community, it's a 1-hour-plus video. So the impact it has on the community. So I started receiving messages like people, oh, yeah, I built this dashboard with your API, and you can see here these dashboards, even like some are public through these links, others like BBA by Alex, very nice visualization, very rich visualization, but the most important thing is all these messages saying that I had a blast to work on this project. You gave me the opportunity to work, to combine my passion with data and build fun projects and have fun and understand the game we love from a different angle. And that, for me, was the biggest reward working on this project. So yeah, I'm glad that it's having this kind of impact on the basketball analytics community. So, what is the future of the library? This is a public open source endeavor, all right? So please, if you're into this field, contributions through pull requests, bug reports, feedback are all very welcome. If you're using it, please keep your projects also public and contribute to the community. And there will be more data and features added to the library soon. So this is also work in progress. But yeah, please bear in mind, this is an open source public project. Treat it likewise. Before I move on, I want to highlight a little bit the difference between NBA and EuroLeague basketball analytics. So in the NBA, the culture is much more mature in terms of data analytics. So the official NBA provides publicly available free API endpoints, very rich play-by-play data, provides a set of tools that you can get for free, more insights about players, about teams, and more advanced data, and all this free and well documented. In comparison to EuroLeague, in Europe, there is no official API. It's almost hidden, as I explained. The play-by-play data, I mean, what is happening during a game is very basic. Even the players that play during the game, the lineups, we have to process that and extract that information, and very often it's not correct because the way the play-by-play is documented is not correct. And there's no more advanced data compared to NBA. We have to derive all that with more analysis. And in general, the European culture is very much behind the NBA. So we are trying to get data from national leagues, and it's almost impossible. So that is the reality right now between NBA and European basketball. So how we use, the next section is how we use this data to unlock insights with knowledge graphs. This is the knowledge graph team. As I said, it's again, we teamed up with the Shot Club podcast. Nikos and Prodromos are the two guys in front of the cameras in this podcast. Nikos and Stratos and myself will provide them with some advanced analytics. And Stratos is a knowledge graph engineer, the knowledge graph expert, Nikos also. And we were using this data, and these two guys had this idea, why don't we put this data on a knowledge graph? Okay, and that created our one of the first attempts to put play-by-play data on a knowledge graph. So apart from that, we cover many aspects of the game, all right? Like shot locations, we go on and produce a lot of like clutch players. I don't want to bother you with that. Scouting reports for teams, like their shot locations, profiles, lineups, most effective lineups, and all this kind of stuff. But I want to focus mostly on the knowledge graph bit. So what is a knowledge graph? So the term became popular in 2012 by Google when they introduced this knowledge graph search. And instead of focusing on matching strings, they focusing on matching entities to understand the real world. And that provides users with a deeper context, new connections by displaying rich information for people, places, and things. So a very common example is if I Google Taj Mahal. In the past, it was a string, and I used to get results before the knowledge graph era. I used to get both results for the monument and also a musician. Now, if I Google when was Taj Mahal built, it understands built means a building, and that connects to the monument. So it gives richer context. And of course, all the major players followed up and implemented and started using knowledge graphs. So a graph consists of nodes which represent concepts. For example, in this example, that's one node. It's Bob, it's a person. This is Mona Lisa, it's an artwork. This is another person. And also the edges. The edges represent relationships between two nodes. So for example, here we say Alice is a friend of Bob. Okay, this is the relationship. And also between these two, Bob has an interest in artwork, in Mona Lisa. And you can see we can have this is a whole knowledge graph with different type of edges, different type of nodes, and the relationship. Leonardo da Vinci is the creator of Mona Lisa, and so forth. And so the point is that knowledge graph power apps like search engines, recommendation systems, chatbots, and they enhance this contextual relevance and inference. Of course, they can continuously grow and evolve by integrating new data sources and information. And also, they're very powerful because they can be interpretable both by humans and algorithms, so bridging the gap between raw data and AI-powered insights. And knowledge graph act as a structured, verified source of truth, particularly in the modern era of LLM. So they can be used to reduce hallucinations and ensure more accurate outputs. So I've mentioned before the play-by-play data. So this is how it looks like, all right? So every time something is happening on the court, is documented. Like, I mean, the very basic actions. For example, this player made the foul to this player, the foul drawn. Then this was substituted. This player came in. This player had a missed free throw. He made the next one. And then after that, this player made the three-pointer. So everything that happens, and of course, that was assisted by none. So it's sequential timestamp record of every action that happens on the court. Okay, passes, shots, fouls, and this kind of stuff. And it's very, very useful because it includes detailed metadata like player IDs, their names, game clock, when something happened, shot location, outcomes, and things like that. So the point is that all this information is complex and interconnected. Okay? And what thrives with heavily interconnected data? Knowledge graphs. Okay, that was the brilliant idea that Nikos and Stratos had. So this is heavily interconnected data. Why don't we put it on a knowledge graph? Why don't we put the play-by-play data on a knowledge graph? And we can see here, like, you can follow the action of a game. So there was at some point during the game, there was a turnover. And this turnover was done by this player who plays in this team. Okay? Because of actually the turnover, the next action was a steal. Actually, turnover because someone stole the ball. Who stole the ball? This player who plays in this team. Okay? And because of the steal, this player made the foul to the player who stole the ball to stop the transition. So you can see the sequence of actions, and also everything is documented here on the knowledge graph. Okay, the players, the fouls, and everything. And that's only a tiny bit of the action happening during the game. So the benefits of that of this kind of representation, it enables us to do complex queries that are difficult otherwise with tabular data. Okay, we can do with a simple query, we can get so much information that with tabular data would take half an hour or an hour of analysis. And also, it improves AI insight. So we can do easier predictive analytics or strategy optimization through substitution patterns, timeout play design, and also conversational sports assistants like chatbots. All right, so that you can do like with natural language, you can request any kind of information, and the knowledge graph will fetch it and return it again in knowledge graph in real time. Will return it in natural language in real time. So also the chatbot capability is very, very important. I'm not going to cover that, but these are samples of queries. They can be simple to very complicated. The point is that we can ask questions like this player, how important is in the graph? Not in the team through traditional statistics, but in the graph. This player, how important is in the graph? And using graph theory, we can come up with new metrics that are graph theory, coming from graph theory, not from basketball. And we can identify influential players, not through the traditional stats or advanced stats like blocks, points, and things like that, but how central this player is in the graph. Okay, and that is, you can come up with new basketball indices and metrics, and that's a game changer because unlocks totally different insights because of the player's position in the graph. And this is the assist network, a very simple application. So why is that important? Obviously, we know if you are familiar with Euroleague, Kostas Loukas, yes, he's one of the top point guards in the Euroleague. Of course, he does a lot of assists, but it allows us to see some duos that are not obvious with the naked eye. Okay, and we can create like visualizations like that to uncover more duos, who assists to whom. Okay, so the last section is about simulation. So we have this API, we get the data. So I want to cover how we build simulations to that. So that's the motivation. So the idea initiated by Georgios Giasemidis. He's known on Twitter world as Figure 8. And he asked me, can you simulate the EuroLeague season until the final? And the word simulate triggered me because simulations are my day-to-day job. And my bread and butter. Funny enough, Liz Bullen is talking in another room right now about agent-based modeling. So that's my day job, essentially. And I love simulation, so this triggered me. I said, yes, I can. So that's the basics of the methodology. In order to do this kind of simulation, you need 3 ingredients. A prediction model of games, meaning a model that gives a probability for the home team to win, the current state of the standings table, and the schedule at the end of the season. If you have these 3, you can build a simulation model. This is the recipe for each round and each matchup. In the schedule, we apply the prediction model to estimate the probability for the home team to win, then stochastically decide if the home team wins or loses. That means, let's say the probability of the home team to win is 0.7. We draw from a uniform distribution a number. Let's say this number is 0.5. If it's less than 0.7, then the home team wins. Otherwise, it loses. And we repeat that. We update the standings table for all rounds until the end of the season, and until the Final Four and all games until the very end. Okay? But as I said, the model is stochastic, so that needs to repeat it multiple times, meaning multiple universes or multiple runs of the season, not just one instance. And yeah, if you think that this is Dr. Strange, was asked how many universes alternative universes did you see? He said 14 million. How many did we win? He said 1. So in all simulations, we run 10,000 runs. Okay, and I'll explain the output format in the next slides. So this is a little bit about the particular prediction model we used. But again, the framework only needs a prediction model. If you bring me a prediction model that returns a probability for the home team to return, we can run that. But here I'm explaining the particular prediction model that we used in our simulation. So it has 2 parts, one based on ELO scores and the other on net ratings. ELO scores is, if you're familiar with chess or tennis, is like when 2 players play and there's a very good player and a weak player. So if the weak player beats the strong player, then they get more points in the ranking. And so we can apply that to any game with 2 teams or 2 persons. All right. So, and the point for that is that allows us to have the ELO scores from the beginning of the EuroLeague history, the beginning of data, and it captures the traditional powerhouses, and it also solves the cold start problem. When we are at the start of the season and we have no other information, no other statistics about the teams, how we're going to simulate. But if we look at the, this is the form of the teams from previous seasons captured in ELO score, then we can use that, okay? Net ratings, what net ratings is one of the advanced analytics. If you're not familiar with the term, don't worry, because essentially it's how many points a team scored minus how many points a team conceded. But because we are data scientists, we need to normalize that, okay? So a net rating is a normalized version of the difference between points scored minus points conceded, normalized by number of possessions, but don't worry about that. Okay, the point is that net ratings capture the momentum of the teams during the season. So when the teams start playing, they build momentum. The net rating is a very good indication to show, if the team, if it's very positive, then that means the team score more points than they concede, normalized, and that shows a very good form. And the prediction model is a weighted sum of these two. Okay, if you know about ELO score, this naturally converts into probability. You can easily convert that into probability. So we take a weighted sum of these two scores, and you can tune the weight as well. So in the beginning of the season, the weight is 0, so we give all the importance to the ELO ranking because we have no information about net rating. But at the end of the season, when net ratings captures everything we need to know about, no, not everything, but captures a lot about a team's performance, and we don't know about the the history of a team in previous seasons. We set W to 1, but you can set it to any value between W0 between 0 and 1. And again, that was a particular prediction model we used. Bring your own model. It could be a machine learning model, and then we can run the same simulation. So these are the type of results. So these are the typical teams in Europe. And we can predict which teams will finish top 4, top 6, and top 10. 6 because these are not random numbers. Top 4 teams have home advantage. Top 6 go directly to the playoff, and top from 7 to 10 they play the playing games. And these also we can predict the number of wins a team needs to finish first, second, or third. And if you compare that to what actually happened, we ran this simulation at the round 30, 4 rounds before the end of the regular season, all right? And if you compare these numbers to what actually happened, we are one win off. So that's actually pretty good. Even the model is very simple. It's very powerful. We can also run until the very end, like Final Four. Final Four is when the top 4 teams play against each other. The final, and who is going to win it. So, and also, what are the most probable probable pair of teams in the final? So these are 2 Greek teams, so it's going to be hot. That's the highest probability. And if you can see here, the teams with the top 4 teams with the highest probability to go to the Final Four, actually these teams went to the Final Four, which is in 6 days, starting Friday. So the model is doing pretty well. So I would like to conclude here. Access to Euroleague advanced data was never easy. And this project is an effort to democratize and popularize Euroleague data analytics. And in my opinion, that's my personal modest opinion, Euroleague has a long way to go in terms of data accessibility and richness. However, even with the current publicly available data, there's so much analysis we can perform. Knowledge Graph provides a powerful tool for uncovering a new dimension of insights, which is fast and efficient. And also, we can simulate whole seasons and and predict teams that go to the Final Four and their chances. So more to come in the next basketball season. So thank you very much, and I'm happy to answer any questions.
Great, thanks, Georgios. Do we have any questions from the audience? Just lift your hand up.
Hi, so once Once again, thank you for the talk. It was very interesting and insightful. And a lot of the data analytics you've gone through, it's all about the kind of teams. And I'm not sure if there's anything at the moment. Would there be potential to kind of do, to kind of use this kind of data to do to do it on even more kind of granular, minuscule things, like maybe specific teams, specific players, even like other factors too, or other things?
Yeah, absolutely. The APIs also cover team statistics. I mean, historical as well, and we could. Yeah, there's so much you can do at the player level. The most obvious is identify, talent. The problem here is this covers only one league. To identify talent, we need access to many leagues, like national leagues, as I said, and that is the real bottleneck at the moment. National league data is not public, is not free, is not publicly available. Some data vendors, there are a few, 2, 3, 4 data vendors that have this data, but they charge enormous amount of money. And I think that this is the issue. So yeah. So in contrast to the NBA, where college data is also free and you can do so much more. So that's why I want to emphasize that the culture in Europe is a little bit behind yet.
Any more questions? Yep.
With knowledge graphs and stuff like that, you were talking a lot more about like actual numerical data. Does it also work well with like textual data and semantic-based stuff as well, or is that kind of would it require a bit more work as well? Because it's
no, I mean, yeah, most of the data is not numerical. It's like player names, player positions, type of action, which is like it's an assist. So it works very well with that, yes, because as I showed before, even a knowledge graph can capture all these relationships. It doesn't have to be numerical. So yeah.
And how does it do with like unstructured information being fed into it? Is there a bit more work there?
It does work as long as you have a schema and you know the relationships of this unstructured. There might be a little bit more work to put in the knowledge graph, but once you know, okay, this has this unstructured data has, oh, you mean images and things like that, or
images, or just like unprocessed text or anything like that?
Yeah, I mean images. If you know this is an image of this player, you can associate it to the knowledge graph. So yeah, absolutely, yeah. Even text, you can process it. And great question. Yes, because very often injury reports come into their reports like text. You can process it and say, okay, this relates to the history of that player. So yeah, you can do that. Yeah, as long as you know the relationship between the different nodes.
Okay, brilliant. Any more before we?
Yeah, thank you for the insights. That was super interesting to find out about. I was wondering, so you took us through like the evolution of sports analytics, like with it baseball being the beginning and basketball. I'm wondering, like, since football is like the biggest sport of this nation, I don't think like football analytics is too big.
Actually, it is. In Europe, it is. It is very big, and player tracking. I mean, there are so many initiatives. Expected goals. Are you familiar with expected goals? Is like towards that direction. And if you follow what is happening, there's much more happening in football because also it's much more popular. There's more money. Yeah. Let's be honest. That's the reason. There's much more money. There's so much more happening in football, particularly in Premier League, in La Liga, Spanish League. Teams invest in that because to identify talent, also for team formation. And this, you can see that also when you watch the analysis of a game now, more analysts, broadcasters go into their tools that they can analyze, like heat maps. So yeah, there's so much more. And what is very key is player tracking. Once you have a player tracking algorithm, you can do amazing stuff. And the player tracking algorithm for football is much more mature than basketball. Yeah. Okay. So I can give you like a couple of names in a football space. So to follow, then yeah, there's so much happening. Yeah.
Any final questions? Yeah, one more.
Yep. So thanks for the talk. It was quite interesting. One thing that you mentioned is obviously mentioned about the network that you built and things like that. Was that used in the actual modeling itself, or was that just for the analytics parts?
Oh, the knowledge graph.
Yeah, knowledge
network.
graph. Sorry.
At the moment, the knowledge graph is used only for the analytics. We haven't tried to do any predictive stuff. No, it's not used in the simulation. That's the question. It's not used in the simulation. It's used only to derive some very complex analytics. But essentially, we want also to use it for predictions. And doesn't mean necessarily game predictions, game outcome predictions, but so many other stuff like injuries, things like that. So if you can predict when a player is likely to get injured, that is very, very, very useful insight for a team.
Great. Thanks.
Cool. Can we give Georgios another round of applause before we